Howdy everybody in YouTube land. So this was a ship-in for repair. Um, Most people are probably not aware of this, but I do accept repairs on a selective basis. Most people try to reach out to me in the comment section, which is not the correct way to do that. My contact information for requesting things like this is actually on my YouTube channel. So if you go to my YouTube channel, you can find my business inquiry contact section. So everything's there, which is exactly what this guy did. So now, this one's in for repair. The complaint on it is there's no power. Other than that, I don't know. But I do want to preface this by saying this is not how you pack a computer for shipping. I'm noticing this more and more often with shipping in general as people are starting to get lazy, and I can see why. It's because the cost of shipping is astronomical now. Like this was, well, I'm looking at it on the front. I don't want to give my address away on video, but it's $37 to ship this thing. So I get it. It's expensive, but it's going to be more expensive to replace this machine if it gets destroyed in shipping. And I've seen so many horror stories on Twitter, YouTube, Discord, all the other social medias of things arriving destroyed because there's no packing material. And this is no exception. So what we have here is there's plenty of padding here and here. Not great, but that'll work fine. The problem is here. That's it. That's all we have. That's it. There's no support there or there. So I am going to be 100% amazed. I mean, there's some padding here, but, I'm going to be 100% amazed if this thing arrived intact. It's going to be interesting to find out. And if it did, this person got incredibly lucky, because when I get this fixed, if I can fix it, because there's never a guarantee I can fix it, right? But if I can fix this thing and the customer approves of the repair, it's going back in a different box. It's not going to get shipped like this, because this is the wrong way to ship something. So there it is. It's an LL Bean case. Don't think it's original. I'm not entirely certain, but well, are we going to have something that's viable for repair, or are we going to have carnage inside? Well, let's see if the padding of this case, because that's all we had, essentially, except for here and here. Save this thing, shall we? So here we go. We get to open it up. This product is designed to help protect your... Ooh, so this is a special laptop case. So this is the original adapter. There is some padding in here. Not much, though. But that certainly looks like a Toshiba computer to me. So here we go. What do we have? The big unveiling. We have a T1200xe. Yay! Another Toshiba. Actually, I don't mind working on these. They're not bad machines to work on, as long as they're in decent condition. Which this one appears to be in... Well, we got some issues going on here. I think someone got nail polish remover on here, because that's exactly what that feels like. So, but that could have been, who knows when that was. That could have been 20 years ago. But anyways, so let's see. So yes, we have a Toshiba T1200xe. So it's got some kind of thing here. Well, at least they were wanting to protect the keyboard and screen, at least. Which, yeah. Anyways, I don't see anything broken anywhere. Screen's good. No screen cancer, because these types of displays are notorious for screen cancer. I don't see any of that. It's got that infamous floppy drive that my T1000 does. Yeah, it's a hyper thin drive, and they have a belt. I'm pretty sure it has a belt. And you can't get to the belt without taking the heads out, which means you're going to lose the head alignment. So I've not figured that part out yet. So, alrighty then, we have our standard DC 12 volts, positive center, luckily. There's our docking port, just like the T1000 I have does. There's our CGA modem. Hey, it's got a modem built in. Serial port and parallel port. Keypad. I don't know what that is. I've never seen anything like that. That looks like an Atari 2600 power connector to me. But yes, it is a T1200xe. Now, I do not know if there's a hard drive in here or any of that yet, but that's beside the point. The complaint with this machine is it does not power on. Now, if I were to fathom a guess, we're going to have capacitor problems with this machine, or a blown transistor like my original Toshiba, the one that I own, has. So, yes, that battery does not come out. That has me slightly concerned, to be honest, because, yeah. Because the last thing I need is a corroded battery stuck in here. Wow, it does not want to come out. I hope it's not corroded. Nope, I don't see any corrosion. But we don't want this in there, because we don't need... Yeah, actually there is a little bit. Yeah, we don't want that in there. Matter of fact, that needs to get cracked apart and the cells removed out of this before it gets worse. Because if anything, you want to at least have this is just to fill the hole, so it doesn't look like this. You can repack the cells if you want. I would never use a machine like this enough to justify the cost of batteries just for them to go bad in a few years anyways. So it is not, I would never do that, but to each their own. Some people would actually do it because they would use this as like a daily writing machine or something with WordPerfect. I mean, who knows, but for me it is not the case. So all right, there's a couple things going on here. Date 92. That puts it right in that era. That puts it right in that era of leaky capacitors. So we've got a couple of variables here. We have the capacitors in the machine, and then we have the capacitors in the power supply. So which one is it that's stopping this from turning on? But I don't like powering things up and trying to turn them on with potential bad capacitors, because you could do more harm than good. As we saw with my T1000, where we had the fried transistor that had a hole blown in it. So I don't like doing it. Although this one was attempted to power up anyways, but I'm not going to do any further damage to it. So what I'm going to do is, judging by the date code, I'm going to take it apart and I'm going to check the state of the capacitors in the machine first. That is beside the point. I can work on that later, but the important thing is to see what's going on inside there. So I'm trying to take it apart. Well, step one is these gooey ass things are going to have to come off. I'm going to have to get those removed because it's getting all over the place. The other thing I noticed too is that's bent. I'm wondering if that was always like that or if that happened in shipping. It's kind of hard to say, but that's what was binding that battery up and holding it in from moving. But yeah, these have to come out. They're very gooey and they're getting all over my fingers, these old feet. Behind the memory cover, we have one proprietary RAM expansion module. Not surprised it's proprietary, but at least we have one of them. Oh yes, my suspicions are confirmed. As soon as I lifted the keyboard up, I got a whiff of that smell. That dirty, rotten fish at the edge of the sea smell. Yes. We are definitely going to have pissers all over this board. Ow. Why did I do that? Oh, I can smell the aroma even just sitting here. I wish we had smell-o-vision to explain that scent I got. Anyone that's recapped machines before know exactly what I'm talking about. So behind the keyboard plate, we have a battery bomb. That's going to have to go away. Can't have that in there anymore. We have our 12 megahertz rated ADC 286, which is a CMOS version. We have our typical of the time period Toshiba Gatorade. Then we have our keyboard controller here, which looks like it's an Intel part. And then some proprietary Toshiba thingamabob there. And we have our RAM. Anyway, so we need to get there. There's the BIOS. I can't remember if these machines had hard drives or not. I don't think that they did, but I could be wrong. Maybe there is a hard drive in here. Yeah, there is. Disk in use C. I wonder if this is the Toshiba that uses the proprietary BIOS codes for the drive types in here, so it only works with certain drives. I think people have modified the BIOS that would allow other drive types. Actually, it wouldn't surprise me if you could modify this BIOS and then shoehorn in the XT IDE ROM in here so it'll work with any drive on the IDE bus. If it's IDE, that part I don't know, but that's broken. Brittle plastic disease. Okay, what do we got going on here? I gotta fight with this some more. After taking these 3 screws out and the 2 in the rear, I was able to lift it up this way and pull the LCD connector out, get out of the way. But yes, this is bad. You can see where it's just puked its way over and corroded the metal. It's terrible. So yeah, that's what it was. This is what I was afraid of. That's got to get fixed. Alright, so now here comes the next thing, right? So we know we have a bunch of bad caps. Now, this doesn't belong to me. This belongs to a person that I'm doing this repair for, right? So, I am genuinely curious because here's the scenario, right? People that are out there that do this, even if it's a side gig or if it's for a living or whatever, people that work on this kind of stuff for a living, or even if it's a side hustle for other people, I would be curious how you factor out what to bill for something like this, right? Because you can run into a red herring really quickly here. Because let's just hypothetically say, okay, well, it's going to be $100 or $150 to fix this thing. Just throw a number out there, right? Just randomly throw a number out there. Okay, well, we know the first line of defense is all these capacitors. Well, we'll clean this board up. We'll patch any broken traces. We'll replace the caps. $150 are down the road. But it doesn't always work out that way. Because the problem with this stuff is, well, it's like a video game, right? This is the first boss. Well, you got to do that. It's going to be $150 to get past the first boss. But we don't necessarily know if there's a second or third or fourth or fifth boss down the line, right? That's the problem with this stuff. So let's say we could replace all the caps, $150, fixes it, out the door, it's done. But it's not so fast. What if now the hard drive's bad? Well, now we got to find a replacement for the hard drive, so that's more. Oh crap, we replaced the hard drive. Well, no, now we got a bad RAM chip. So we're getting a RAM error. We got to replace the RAM. Oh, now 3 or 4 of the keys aren't registering on the keyboard, so now we got to fix the key switches, or on and on and on and on. Well, the battery, it needs the battery to run, so now we got to fabricate a replacement for that. Let's, for example, oh, now we got to replace or fix the charger brick that runs this thing. That $150 goes quick. You'd be $500 in this thing, and it ain't worth it, right? It's not even worth $150, but you get my point. So I'm just curious. I'd be curious to know in the comment section, anybody that does this stuff for some kind of, customer work or whatever. I'm curious how you determine billing on something of this vintage. So, and for me, I already know I'm going to lose money. Because for me, I'm doing this more for fun and more for content on video than to make a profit. Because this is not my profit. I got a day job, right? So this is more just for fun. But I'm curious for people that are actually doing this to make somewhat of a living, how you determine it. Because in the old days, it was time and material, right? But something like this, you'd be $500 into it, which it would make sense in the old days, because these things were like what, $1,500, $2,000 new. I mean, you'd be $300-400, and it wasn't that big of a deal back then. But also, back in those days when this stuff was relatively new, we didn't have all of that going on with it. So I'm just curious how much people charge for restorations when it comes to computer stuff like this. What would be a good estimate for a full restoration on something like this? So anyways, I'm just it kind of a tangent now, but let's get the rest of this apart and see how much damage we're dealing with. Holy crap, the leakage is so bad. When I pulled the screw out here, it was dripping off and running all the way down the screws. That is bad. I've worked on a lot of stuff with capacitor leakage, but I'm going to say that this is one of the worst I think I've ever seen. I've never encountered something this bad before. I'm trying to figure out how this thing comes apart. There we go. That is bad. Wow, it's so bad. Oh man, this is why I was smelling it so bad. Yeah, that's a problem. So, get all that out of there. More Toshiba Gatorades. Oh man, so you need to come out for obvious reasons. So, did this one work all the way up the pins and crowed the pins? Yes, it did. So, that's gone. Garbage. It's just a JST connector on the other end of that. Not a big deal. So, I'm trying to figure out how this thing actually comes out. Wow, this is so bad. I've never seen capacitor leakage this bad before. Whew. Yeah, don't mind me, I'm just a little bit overwhelmed. Now, I don't cuss much on this channel, but holy shit. That is not salvageable, I don't think. Oh, this is bad. Oh no. I honestly, I don't know. That might be it. Yeah, we might be done here before we even started. Also, just as I feared, someone tried to run this with the caps like this. This is why I didn't plug it in. But someone already beat me to it because look what we got here. That transistor is completely blown apart. It looks to be the same one as that one next to it. Q21. So if that's blown apart, how much more damage has been done to this thing? Yeah, this is man, this is not good. There's so many traces that are completely eaten away, like here near R48, and you can kind of follow it up and find some in other spots, but that's not surprising because the caps are right there. But yeah, this is the worst. This goes down as the worst I've seen. That's not a battery bomb, because this looks like battery bomb damage. It does, but it's not. Well, I just got one thing to say though. Recap your shit. Don't let it sit around, and don't attempt to plug it in either, because this is gone. This is gone. I can fix it. If it were mine, I probably would, but it's not mine. The owner's gonna have lots of labor time in this thing. I don't think it's gonna work. Because remember what I said about the $150 just a minute ago? This is not a $150 job. That is probably a $500 job. With the amount of work you're going to have into it, you're going to have days of labor patching this stuff up. So it's a controversial topic. It really is. When you're working on something for yourself, when you're doing your own little thing or doing it as a hobby, it's probably not so bad, but this is a lot of labor. This is a lot of time. And there's a lot of damage for a machine that has no schematic. So, yeah. It's unfortunate. But this is what happens. And a lot of that has to do with bad storage conditions, too. It was probably thrown in a barn or an attic for 20 years. Alright, yeah, this one's not repairable because I tried to clean some of this up and the screen print is gone off of those chips. And those are ICs and not transistors. So I can read 1, 2, but these three in the middle, I can't. And they've got to be replaced because look at them. So it's beyond repair. It's unfortunate, but this one's destined for the graveyard in the sky or e-waste pile. Wow, that sucks. But I think he owns another one of these that has a broken screen. I'm gonna have to get in touch with him, and maybe we can make one good one out of two. I don't know, but that power supply's gone. It's not salvageable. It's unfortunate because there's no schematics, so there's no way to know what these originally were to even begin to know where to start. So it's unfortunate, but that's where we are. All right, so I've been sitting and I've been thinking about this and been mulling this over. The guy has another one of these machines. He's going to send it to me. Perhaps we can make one good one out of the two, and then just I'll send them back as parts or whatever we do. We'll figure that out. Because the other one he said he's got a cracked LCD panel, so it's no good. But there might be some good parts. Like it might be less damaged than this one is. I cannot find the info on these parts. I can find those. These are labeled C5, which is a voltage low dropout regulator, but there's an attribute that determines what voltage they are. Well, I don't see that on here. And then this one, which is an RDX4, can't be found at all. I don't know what it is. I'm going to assume it's another low dropout regulator, but I cannot find any details on it. However, I did find the maintenance manual to the Toshiba, like every Toshiba has, and guess what? The power supply interface is documented. So I've already went through here and I've already figured this out. So this power supply is not just a power supply. This power supply also contains a smart management controller for power, like ACPI level stuff before that was a thing, right? So this contains the power management controller for the system and the battery. So this can monitor the state of charge of the battery. It can, turn the battery charger on, off. All of that stuff is controlled by this board. Now the Toshiba T1200 is not nearly as complicated. It's just a bare power supply, and someone made a retrofit of that particular power supply to make those machines work again. This one, it doesn't exist because it's a lot more complicated. So if you wanted to replace the battery and make the battery work again, you would have to replicate all of these features or fix this board. However, if you didn't care about the battery, it doesn't really matter so much, does it? So from here's what I've understood so far. Now we've got our standard ground VCC and all that stuff. We have RAM power, which is this battery here, and that's what keeps the RAM when the main battery dies and you need to replace the battery real quick and swap it. You won't lose what's going on. That's probably less critical now, so I could likely wire this straight up to VCC 5 volts and just be done with it, right? We have our 12 volts. We have our backlight voltage. We have our negative 9 volts for the modem and serial and all that stuff. And we have our LCD power, right? I think this is the negative or positive 22 volts or whatever for the VEE for contrast drive and all of that because it's a passive display. We have a backlight on control signal. So that I think is an input to the power supply itself. I forget how this is done because these are input. No, these are inputs to the motherboard. It has to be. It goes from power supply to motherboard. So this must go from power supply to motherboard. So BO on, backlight on. So it tells the motherboard that the backlight is on or off. And then I'm not sure what this signal does, but it's an output from the motherboard to the power supply. This is an AC input signal. That tells the motherboard that the power plug is plugged into it, so it turns the light on the indicator panel. This is the clear signal, which is likely this button here. This is a reset button, which reboots the machine. And that is probably connected to that. And then over here we have internal display, which is an output to the power supply. This is an output to the power supply. from the motherboard, which makes sense because when you close the LCD, which is this button here, it probably toggles this, which tells the power supply to shut off the LCD power and the backlight power. So it's a little bit of power management built into it, which is controlled by these chips, right? So we have that, and then we have the charge indicator, which turns on the charge LED. But then we have this, I'm not sure. And then we have this beep in signal, which goes to the motherboard from the power supply. That probably is connected to the buzzer or the PC speaker. So when the battery gets low, it'll go beep, 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 and all of that crap. So that's probably that signal. And then we have these two. Chances are, those are the communication bus to the microcontroller. So I don't know what that protocol is, but that likely tells the motherboard, hey, what's my battery level? Hey, I want to turn the backlight on or off or whatever, you know what I mean? So it's the power management. It's a very early form of power management before all of the Energy Star, ACPI standards and stuff were standardized for PCs. So this is a very early form of it. I could delete all of this and just make a power supply and just provide the voltages, but the problem is none of that stuff's going to function, right? The system is not going to see, turn the backlight on and off on its own. It's not going to be able to read the battery voltage. It's not going to be able to do any of those things. So, if I design a new one, otherwise I could probably, reverse this into a schematic or something and then make a new one using a modern technology and just move the chips over. There's so many different ways of doing this. Also, I've been staring at this a bit more. And, I mean, yeah, it's bad. It's very bad, but it's not terrible. I think, I might be able to fix this board if the other board he has is no count. We'll have to see. We'll have to play that by ear. And yeah, this thing's got another battery too. Stupid, another Varda bomb. And that's the time of day real-time clock battery because there's the crystal. So, yeah, that's what I got right now. I mean, the good news is I can kind of figure out what those are if I chase these signals back because I know what my expected voltages are. So I can figure out what these are meant for. These are low dropout regulators. So it's possible they're using this as like a primitive form of a ADC. Like if the battery voltage gets low, it'll start switching these off one by one so then the microcontroller can read that. I don't know. There's too many unknowns. But this power supply is over-engineered for what this thing actually is. So, yeah, that's where we're at. Alright, so every single one of these capacitors, besides maybe two, were extremely painful to get out of there. So, like, I had to pull the caps out physically so I can leave the leads behind. So I could use flux and a lot of heat and my two soldering tools over here to try to pull each pin one at a time. So what I did was I grabbed this pair of whatchamacallits here, clipped it and used that as kind of dangling down as a force, so I was holding the board and letting everything fall out. But yeah, that was extremely difficult to get out of there. So now I got to clean this up, and I also fluxed this area up here to try to absorb some of this corrosion a little bit better because it's quite nasty. Now, I'm curious how this works. I'm on this funky little gimbal thing. See? It's made by DJI. So I'm curious how well this actually works. I'm holding it by hand. So anyways, I went ahead and did a little bit of flux removal here after trying to clean this up as much as I could, but I'm starting to think that those are gone. They are. Yeah, those voltage regulator chips they're gone. There's no way that's ever going to work. So yeah, it's unfortunate, but I'm going to have to figure out what they do and find replacements, because if I can't, then it's never going to work. I did remove that one, which was completely burnt up, and that guy is over there right now. So, yep. And then I removed these two just to get them out of my way. I'm probably going to remove all the rest of them so I can clean them up and remount them, because this thing is just absolutely trashed. So, yeah, it's unfortunate. Just is what it is sometimes. That's just how the cookie crumbles. But we'll see. We'll see how well it works, if we can ever even fix it. But, well, there's only one way to find out. Well, the owner sent another one. And this one is even worse than the other one. So he sent me this for parts to see if I can get the power supply out of this one and fix the other one, but I don't know, because it smells and looks worse than the other one, but we'll see. Alright, so now we have the second board from the parts machine. And this one's not nearly as bad. I mean, it's still pretty disgusting. It is, yeah, and we've got a fried transistor there. But those C5 marked components are not eaten away. Are they good or not? Nobody knows. But they're not eaten away. So I think we have a much better chance with this one than we do with that one. But between these two, I think we should be able to at least get one working. At least that's my hope anyways. Now that I've quickly cleaned the board off, what's absolutely fascinating to me is how much the capacitor goo gets into the inside of the PCB. See, this proves my point that I've had many times in the past. So when you recap a board after you clean it and it still doesn't work right, even if all the tracers are good, that might be why. Because the fluid gets in between the layers and causes problems with the capacitance and all that stuff parasitically. So that's an issue. This board may not be... I'm going to have to bake this board and drive that out. Or something. Somehow. Alright, so I got the microscope out. And I got the second board cleaned up as best as I possibly could. Got all the caps off of it. And tried to clean it up. I didn't clean this section up yet, but I'm still working on it. I already put a blob over there by R20 because that was broken. So we had some fried MOSFETs, which are just kind of like chilling out over here somewhere. Yeah, like here we go. We got a couple of questionable ones there. But more importantly, in here somewhere, I don't know where they went. There they are. Yeah, we got some fried ones where they died a horrible death. Anyways, so now with the scope, we can kind of... I got a camera head, but I need to get the camera properly lined up. But I'm going to try to get in there as much as I can. It's really, really difficult to do. But let me get the board in the right position so I can, see the brakes, which we're getting them patched up right now. But yes, the C5s from earlier in the video, the C5s are actually C5, and those are transistor paired drivers for the MOSFET. Now, I don't know exactly what it is, which exact one, because there's 3 pins here, 1, 1, and 1, that are not connected. But the data sheet shows that they need to go somewhere, so I find it funny. So anyways, alright, now I got the board in the right position so I can get this adjusted. But you can quickly see that in here, yeah, you can see the brake right there. And you can see the little chunk where I tried to take the grinding tool to it to reveal the brake even more. So we had a brake there. And then we had a break here, which I've already patched to that transistor right there. Now we've got several breaks on this board. We've got, let's see if I can find it. There we go. We've got this 222R72, which is a 2.2k ohm, is broken to Q19 and Q18 here. R71 is broken between right there in the middle. And then up here it's also broken. See that? Which goes to that via right there. So we've got some breaks. Now this section over here. Oh, too far. Yeah, there's those C5s I was talking about. So those guys are all good. Anyway, so I've done this diagram right here. Now this one has, I marked the breaks off. So we've got a couple of breaks here we have to take care of in this vicinity here. Not nearly as many as the other one. The other board had a bunch of them here. So we got some breaks here. We've got only one little break there. But more importantly, over here is where all the breaks are concentrated on this board. Where on this other module, I didn't have that as much in this vicinity here. So I took some transistors off to take some reference photos. But yeah, there's some breaks here, and those two transistors are connected together in a push-pull configuration to drive one of the two MOSFETs here. And then this MOSFET drives the L2, and then this MOSFET drives the transformer there. So yeah, that's all part of the DC-DC circuit. So I'm going to keep plugging at this. I've got to run some patch wires through these vias to make a better connection because they don't really look good either. Yeah, we've got some PCB delamination, but not a whole lot I can do about that. And then that's it, really. So I'm going to start getting some caps thrown in here. I'm going to start patching everything up and hope that we get it right. It's going to be a miracle because these boards just get absolutely soaked and damaged hard. So I've got some capacitors in there, and unfortunately, half of these, actually a lot of these, I don't actually have the right values because they're using like oddball values in there, like 120 UF 25 volt, 56 at 35. Luckily, I do have those because I've seen them used in like SE, or not SE, but LC power supplies and stuff like that. But it's this weird 680 at 10, which I don't have. Closest I got is an 820, so I shoved that in there, which is barely fitting in there. I did have these, so those are in there. But it's these 220s at 35 that I don't have. I've got I just don't see them. So I got 470s at 35, so I shoved those in the holes. And then, unfortunately, a 470 is not going to fit in that one, so I had to take two 100s at 35 and then parallel them up together, and this is not even a low ESR version either, so it's just kind of bodged in there for now. It's not ideal, but for testing, I think it'll just be fine. I got 470s at 25. I got all the other values in there as much as I possibly could. It's just those other ones I didn't have, but anyways, they're in there. Now it's just a matter of going through my diagram that I made and start patching up all these broken connections that I have. And there's probably some that I've missed. It's really hard to test it because of how narrow these traces are, but luckily I have this board over here that I'm going to use for that. So, yeah, it's just, going through it component by component and checking everything and hope it works. So, at best, it'll turn on and work fine. We can only hope for that. At worst, it won't do anything. But if I were to guess, it's going to be somewhere in the middle where we're going to be missing a rail or, or something like that. And then we'll get a flashing AC light. So, but, it may just actually work. But this is it's just so bad how these things get. Alright. It's all patched up now. So Yeah, it's kind of ugly, but I'm hoping I didn't miss one. I'm sure there's one somewhere that I've probably missed. I gotta check them all. It's hard to check them because the vias are covered, so I gotta grind them off on each and every single via to double check where they go to make sure they're actually connected. But yeah. Anyways, there we have it. So now's the moment of truth. Does it work? Does it even try to work? There's only one way to find out. Alright, I don't have a barrel that big, so I went ahead and clipped it in. Got the battery switch here, 12.4 volts, and yeah. No smokage, but you just get a blinking light of death, which is what I expected would happen. So one or all of these DC-DC converters are not coming up. We don't know why yet. I just got to narrow down which converter it is that's not coming online so I can look for. And I guarantee it's more broken traces. There's probably a trace or two that I missed somewhere. But I'm not smoking any more transistors because remember there was a transistor that was completely burnt up on that particular board. So I don't remember where it was, but anyway, so one of those is not coming up, so we need to figure out which one it is. Yeah, so that's where we are right now. All right, so here's what I've discovered so far. I'm noticing the voltage where the battery backup for the RAM. I'm noticing the voltage for that is 12 volts while it's plugged into 12 volts, which seems kind of high, but the battery's not there to produce a load, right? But when you have the main battery connected, which I substitute with the power supply, 7.2 volts, I got nothing here, which is a problem because that powers the RAM. So, and then the RAM, the feedback is connected to this microcontroller. So if it's not seeing RAM power, that could explain why none of the other converters are coming up. Because I took the oscilloscope and I measured the gate array and all of this against the T1600 schematic, which is very similar to this. Very, very similar. There are some differences because with the T1600 they simplified this down a bit. But it's the same in this area here. It's identical. So, there's nothing happening. It's not getting far enough in the process to turn on the converters. So that makes me think there's something that it's not satisfied to even start. So I couldn't find any open traces here. However, here's what I did find. I was getting ready to put this connector back on because the other one was damaged. So I'm going to take the one off of this board over here. But one thing I noticed is I found two more breaks. I found a break between here and here, and I found a break between here and here, which turns this MOSFET on. And this MOSFET controls that RAM power circuit. So, yep, that's a problem. So we got to fix that. And then I got to hope this will hold some kind of residual charge because I don't think this machine will run without the RAM battery. Alright, so I went ahead and patched that up. And I even put the connector on for the battery. And the battery's charging, kind of. However, the behavior does not change. So it's like you press the power button and it's like a half a second to a second it tries to fire up, but then it throws an error. Problem is when it tries to fire up, it's not producing any PWM signals whatsoever. So there's no way anything's ever going to work. So the only thing left to do now is to pull these chips off and look up underneath them for damage. And more importantly, possibly swap them from this board, assuming those are any good. Because if they're both bad, we've got a problem. Alright, so I replaced the gate array. I replaced the microcontroller. I checked all of my signals coming in and out. I even put in the battery. The battery's not really holding the charge that well. But I can't get anything at all. So it's bad. So if I drop this voltage down to like 7.2 and then we move this to the battery input, we're going to have the same problem. Power on. Yeah, see. I've done everything I possibly can, and I'm about to throw the towel in because there's only so much I can do. I know there's no schematic for this besides the T1600, which is very similar. It uses the same sets of chips, but they've simplified the design, so you can't really go off of that so much. Um, so the problem with this particular power supply is it's a very primitive ACPI based style power supply where the motherboard communicates to this power supply and vice versa. So there's a serial protocol between the two. That way the motherboard can turn the screen on and off. It can put it in a standby and resume. It can, you shut the lid and it tells the power supply to turn off the LCD. You can actually physically shut the computer down this way. So there is a project out there on a different model Toshiba where this power supply board was replaced with modern components with a newer design, and it's open source. And it has all the same voltages, but again, because this is a separate board with the primitive ACPI, that means if I were to substitute this, then the machine would turn on and that's it. You wouldn't be able to turn the screen off. You wouldn't be able to go into standby. You wouldn't be able to do all of those things. It would be like the older luggable stuff where you just switch it on and it works and then you switch it off, which might be okay, might not be. I don't know. So, and then the problem is, as far as I know, the protocol for the two communicate is not documented. So, even if you replaced all this with something more modern with the modern microcontroller in your own code, like a PIC series or AVR or whatever, we're not going to be able to communicate with the board without the protocol, right? And we don't have dumps of these chips. This chip can be dumped because it's a 90 series, and there's an open source project out there that can read the ROM from that chip, so that's helpful. But this one can't be. I can't find anything on it. This is a 4-bit proprietary with no external memory bus, whereas this one has got an external memory bus, and this is a Z80 based microcontroller, so you can dump that. You can even use it with external ROM if you wanted and run your code with it or whatever. But yeah, there was a effort for these because there's a lot of arcade machines that use those, but I can't find anything on that one. So unfortunately, at this point, I think that's the end of the road for this one. You got to know when to call it. It has left me defeated. Sadly, it is what it is. I'm not superhuman. I'm not a super tech. It is what it is. Um, there's only so much time, money, and effort and energy I want to put into something like this. And I did pull the chips off of this board so I can kind of get a better idea of what's going on. I may strip this board all the way down so I can get a better feel of it. I may not. I don't know. But unfortunately, we are stuck with this scenario. So it's unfortunate. It really is. It's unfortunate. But there's a way to make it work, but it'll never work right. Not unless this is properly reverse engineered. But yeah, I could. Yeah, actually, the battery is holding. Well, it's only half the charge. It's a 6-volt battery, but yeah, this battery's had it. I'm not surprised. But yeah, so we've got a board that won't run because who knows why. But no matter what, I've tried probing it with my scope. I cannot get any waveforms out of the gate array going to any of the DC-DCs. So something is not being satisfied by this microcontroller pair that allows the power supply to come on. It's looking for something. There's a flowchart in the patents for this, but the patent is newer than this machine, so it's not quite right. But it gives you a clue. But the problem is I don't know which pins and where. I mean, it's a nightmare. Without a schematic that defines the pins along with their valid state, who knows? If I had a working one of these power supplies, I can check all of this and run comparisons to figure out, oh, wait, this signal is high when it's supposed to be low, or low when it's supposed to be high, so it's not working because of that. So let me do XYZ and get it to fire up, right? We can't do that because we don't have the ability to see what's going on because we don't have a functional power supply. So that's it for this, unfortunately. So I'm going to put all this on the back burner for now. I might return I might return to this to a later date. I might not. I have to get in touch with the owner because, again, this belongs to someone else, and I've already sunk about 4 days of time into this thing that I'm not going to be able to recover back. So, I mean, the amount of effort and work I had to do to this thing, if this was a, yeah, there's no way. It's not worth it. The value of this machine is just not worth it. I probably have $1,000 worth of time, effort, and energy into this thing if I were billing a customer, right? Which in this case I'm not. But if I were, there's $1,000 of work I just put into this thing with the amount of labor I've got involved, a lot of research, microscoping, reverse engineering, all of that stuff. There's a ton of time, and it's lost. So it becomes a sunk cost fallacy. So you got to draw the line in the sand somewhere, and I think this is it. So I might revisit this in the future. I might not. So I'm just going to go ahead and finish the video here. Even if it's unfortunate we didn't have a good conclusion on this one. And somebody watching this video may have some stuff that I don't have on hand that could help with this project. But in the meantime, I've got to put it on the back burner. So if you have a comment, please feel free to leave one. Don't forget to hit the like and subscribe and all that fun stuff. And until next time, guys, thank you for watching.